So today we're going to be using the lasers, and we're going to use mirrors, and we are going to prove the angle of reflection. You read about it last night. What did it say? The angle of incidence equals the angle of reflection. Okay, so we're going to be proving that today. So what you're going to need is you're going to plug this in. You will see that there's extension cords around your tables. So you're going to plug in your laser, your power board here. You will need your laser light, and you're going to need the two magnetic strips. And you want to have them stacked on top of each other like this. You're going to put them on your board. Like I talked about yesterday, the back of the laser is going to sit on the strip so that it aims downward so that it goes across the board. If it's not tipped downward, it's just going to go straight out and you can't see it on your paper. Each person is going to get a little square of paper like this, and you're going to put it in the line that the laser light makes. In fact, let me go ahead and plug this in so you know exactly what I'm talking about. So, I'm going to put the laser on the back here, and the laser light's going to look more red when you're seeing it. It looks white because we're on the screen here. But you want to tip it down so that you see a splash of light across the paper. In the directions that are in your CPO lab books on page 19, it tells you to make a dot about a third of the way down that splash. I'm telling you, you don't need to make a dot. Just put the mirror about a third of the way down that splash, like this. And you will see light reflecting off of the mirror. You can kind of see it on the screen. It'll be easier when you're looking at it on your own papers. What you want to do is this, and I'm summarizing what the directions are because I think it's easier if you watch this. You'll take your pencil. You're going to make a line that goes right across the surface of the mirror. You are going to use your pencil, and because it's hard to draw a line here, I'm going to have you make little dots, and then you can go connect those with a straight edge later. So you're going to put a dot where you kind of think the middle of that laser line is. And then you're going to make dots on the reflected line, or the reflected ray, I should say. And then the next person puts down their paper and they get to do it. And they might do a different angle. They could do a really, really big angle, a really narrow angle. It's up to them. But all four of you at your table are going to have a piece of paper like this. Then, unplug this. You're going to take a straight edge and you want to extend out the lines that you made so that you have them going all the way to the edge of the paper. A little hint, you want to leave yourself enough paper that you can actually extend out your lines. I had a student last period who put it really close to the end and he couldn't extend out his lines. We actually glued it to his lab book and then he could extend it out and it worked okay. But I'm extending these. And then what you need to do, and these directions are on page 20, is you need to create what's called a normal line. And a normal line is just a line that's 90 degrees to the face of the mirror. So let me make labels here. This was the mirror. This was the incident ray because it was coming in from the laser light, and this was the reflected ray. Now to make my normal line, I am going to take this protractor, and let me zoom in. This protractor has a tiny little diamond right here at the center point, and you're going to put that little diamond right where all of these lines meet and make sure that it's laying flat against your mirror line. And you want to make a point 90 degrees, so I see the 90 right there. I'm going to make a little dot. And now I'm going to make a line that connects this place where they all meet and that dot up there. And that is my normal line. To measure the angle of incidence and the angle of reflection, I just want to see how many degrees the incident ray is from normal and how many degrees it is from reflected. I'll take my protractor again, but I'm putting it sideways now. I take that little diamond, I put it here where all of the points meet, and I line it up with my normal line. And now I can see that, and I'm looking at the degree marks here, 10, 20, ooh, that was easy for me, 25 degrees. You guys have better eyes, so if it's close, if it's one of the little ones in between, I know that you'll be able to figure out what the degrees are. Now I need to measure the reflected ray. I'll put this little diamond right here where the lines all meet. I line it up with the normal line. 10, 20, 26. It wasn't perfect, but there's a lot of room for error in this lab because that laser line is kind of thick and my pencil's thin. But what you should find out then is that the incident and the reflected angles should be pretty close to equal. We're trying to prove the law of reflection.